this point, we know how to add and subtract matrices, and we know how to multiply them by a scalar. Now in section 2.5, we are going to multiply two matrices together. So in order to multiply two matrices, we need to know how to find the dot product. So in order to find a dot product, the corresponding rows and columns from the two matrices need to have the same number of entries. So a quick way to determine if that's the case, if you write the size of two matrices and say we're multiplying a 3 by 2 matrix by a 2 by 3, this is the number of columns from the first matrix. This is the number of rows in the second, and they have to match up. They have to be the same. So if you write the two sizes of the matrices side by side in the order that you're multiplying them, the numbers in the middle need to match. And then the result that you get after you finish multiplying them would have the size of these outside numbers. So the result of this multiplication would be a 3 by 3 matrix. You'll see as we go along through some examples how that works. But in order for us to be able to multiply them at all, middle numbers need to match. So let's find that product of these two. So this is just one row and one column that I pulled out of a matrix. So if we were writing the size, this is a 1 by 2. This is a 2 by 1. Middle numbers match. I can find the dot product. So in finding the dot product, we're going to take the first number in this row and multiply it by the first number in this column. So I'm multiplying 1 by 4. And I'll just write it out here to show what I'm doing. Multiplying 1 by 4. And then we've also got to multiply the 3 by the 1, and we're just going to add the results together. So I'm taking 1 times 4, and I'm going to add that to 3 times 1. So that's just 4 plus 3, which is 7. So the dot product of this row and this column is 7. So when you do the dot product, you just get one number. So the result is not a matrix, it's just one number. And we need this to multiply matrices to get each element in the product matrix. We have to do a dot product. All right, here we have two matrices, A and B, and we're going to multiply A times B and then B times A. It's important to note here, we'll see at the end, that they may not be the same. Matrix multiplication does not have the commutative property, so the order is important. The order does make a difference. So let's see how to multiply A, B. And first, let's check and make sure that this multiplication is possible. Matrix A is a 2 by 2. Matrix B is a 2 by 2. Middle numbers match, so we can multiply them. And I'm expecting the answer to also be a 2 by 2. All right. So to get element 1, 1 in this matrix, that's the product of A and B, I need to find the dot product of the first row from A and the first column from B. So remember, to find the dot product, we're going to take the 1 times the 2 and add that to the 3 times the 3. So we're doing 1 times 2 plus 3 times 3. And then to get the element 2, 1, so here in the second row but the first column, we're going to take the second row from A and multiply it by the first column in B. We'll get the dot product. So we're going to do 5 times 2 plus negative 2 times 3. So coming over here, trying to get this element is 1, 2. So I'm going to take the first row from A and the second column from B. So I'm multiplying this row and this column, getting the dot product. So 1 times 1 plus 3 times negative 4. Right? And then to get the last element, it's in the spot 2, 2. So I'm using the second row from A, second column from B. So 5 times 1 plus negative 2 times negative 4. Right, and I'll just go through and simplify each of those. So I've got 2 plus 9 is 11. 10 minus 6, 4. 1 plus negative 12 is negative 11. and 5 plus 8 is 13. All right, so here's our matrix AB, and it is a 2 by 2 like I expected. So let's do it the other way. Let's multiply B times A. And again, we've got a 2 by times a 2 by 2. So we can multiply them. The result should be a 2 by 2. But this time, and let me go ahead and write these matrices in the order that we're multiplying them. So this is B, and this is A. To get the element 1, 1, I'm using first row, first column, find the dot product. So 2 times 1 plus 1 times 5. And then to get 2, 1, I'm using the second row and the first column, finding the dot product. So 3 times 1 plus negative 4 times 5. Next, I'm looking for this spot, which is 1, 2. So I'm using first row, second column. So 2 times 3 plus 1 times negative 2. And then the last spot, 2, 2. So second row, second column. So dot product of these two. 3 times 3 plus negative 4 times negative 2. Simplifying each of those, I get 7 minus 17. 6 minus 2, 4, and then 9 plus 8 is 17. All right, so here's AB, and this is BA. You can see that they are completely different. So the order does make a difference with multiplication. Let's do one more. All right, so let's start with A times B. Let's check the sizes. So matrix A is 3 rows, 3 columns, so 3 by 3. And matrix B is 3 rows and 2 columns, so 3 by 2. So I can multiply these together because the middle match. And I'm expecting the result to be a 3 by 2 matrix. So 3 rows and 2 columns. So 1, 2, 3 rows and 2 columns. Looking like that. All right, to get the element 1, 1, I got to do the dot product of this first row by this first column. So 1 times 5, 2 times 1, and 3 times 2. I want the spot 2, 1, so second row, dot product with the first column. So negative 4 times 5, 0, so plus 0 times 1, plus negative 2 times 1. And then third row by that first column, so 1 times 5, 1 times 1, and 1 times 2. Moving to the second column, so I want the first row spot is 1, 2, so first row, second column. First row by the second column. So 1 times negative 2 plus 2 times 4 plus 3 times 3. Now this next spot is 2, 2, second row by second column, finding the dot product. Negative 4 times negative 2 plus 0 by 4 plus negative 2 times 3. And then now I need to do the third row, dot products with the second column. 1 times negative 2 plus 1 times 4 plus 1 times 3. All right. Going through and simplifying those. 13, negative 20, 0, negative. Okay, something's wrong right here. This should be second row by the first column. So this last element should be negative 2 times 2. So I'm going to fix that. Then we get negative 20, 0, and negative 4. So negative 24. Down here we've got 5 plus 1 plus 2. So that is 8. Coming up here, negative 2 plus 8 plus 9. 15. 8 plus 0 minus 6 is 2. Negative 2 plus 4 is 2 plus 3 is 5. There we go. So next we got to do BA. So B by A, let's check the size. B is 3 rows 2 columns. And A is 3 rows, 3 columns. Middle numbers don't match. So this is not possible. We cannot multiply B times A in that order. The last thing in this section, let's discuss the identity matrix. We're familiar with the fact that 1 times any number, so 1 times any number A in either direction gives us A back. So multiplying by 1 doesn't change anything. And we would call, over real numbers, we call the number 1 the identity for multiplication. Multiply by it doesn't change anything. So we also have a similar property for multiplication of matrices. For any square matrix, so same number of rows and columns, there is an identity matrix. And for 2 by 2s, the identity matrix is this one with 1s along the diagonal and 0s everywhere else. And so let's look at an example just to make sure that if we multiply a matrix by this identity, then we get the same matrix back. And we don't even need like numbers. Let's say our matrix was just A, B, C, D. We still can see that when we multiply it by this identity matrix, it doesn't change anything. So I'm going to multiply A by I. So A, B, C, D by 1, 0, 0, 1. And this is a 2 by 2 times a 2 by 2. I am able to multiply them, and the result should also be a 2 by 2. To multiply them, I'm going to do the dot product of the first row by the first column. And A times 1 is still A, and B times 0 is 0. Let me put some more steps in there. A times 1 plus B times 0. And then I'm going to do the second row, dot product with the first column. So C times 1 plus D times 0. Moving over to the first row by this second column. So A times 0 plus B times 1. And then second row, dotted with the second column is C times 0 plus D times 1. Simplifying those, I still get A, B, C, and D. So I get matrix A back. Let's see if it's true in the other direction. If I start with the identity matrix and multiply it by A, which is possible because this is 2 by 2 and 2 by 2, middle numbers match. Doing it this way, first row, first column, so I got 1 times A plus 0 times C. Second row, first column, so 0 times A plus 1 times C. First row, second column, 1 times B, 0 times D. Second row, second column, 0 times C. Plus simplifying those, again, I get A and B and C and D. So I also get matrix A back. So for square matrices, there is an identity matrix. So square meaning the same number of rows and columns. So a 2 by 2, 3 by 3, a 4 by 4. The identity matrix just has 1s along the diagonal and 0s everywhere else. And when you multiply by the identity matrix, you get the original matrix back. So same as multiplying a number by 1, similar to multiplying a number by 1.